Hi, it's time for a music and sound repair. So today we have a lot of music and sound stuff here. This is a model N350. It was made in 1988 and it was sent in by a fellow named Jacob. It's a house that he recently purchased. The system, according to him, didn't work when he moved in. He didn't get any history on it at all, just that it didn't work. There was some mention to him, something about lightning. Whether or not that's the case, it's hard to say at this point. But his definition of the system is it's dead, 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 dead. Nothing works at all, kind of. So what he sent in was his N350 Master. I have the transformer, low voltage transformer that powers the system. I have the 8-note chime module. And he also sent in the world's most expensive cassette player. This is a CTG, CT for cassette tape, G for gold, because it's the 80s and everything was black and gold. This, according to him, does actually power on, although he said nothing goes around and you can't eject the tape. So that's probably a belt issue more than anything else. I'm not going to worry about this right now because we need to get this working first. Now, according to him, nothing works at all. So, and since there's no history, there's no clues, so we're starting at 0. We're also going to put the chime module aside because we're not worried about the chime module right now because it may be fine, it may not be, I don't know. The first thing we have to do is we have to get the master station working. The first thing we're going to do is we're going to move this out of the way and we're going to take a quick look at the transformer. I have it wired up to my bench power supply for power, and we're going to measure the output of the transformer and see what we have. So this is a genuine music and sound transformer. Don't know the model number on it because it doesn't really say. However, according to the label on the transformer itself, it is supposed to be a 24 volt center tap 40 BA transformer, and the wire codes on it are yellow yellow and the center tap is yellow red. And you might actually be thinking, what's a center tap transformer? Center tap transformer is a standard class 2 low voltage transformer that has 3 output wires. Most people are familiar with transformers that have 2 screws on them, but some transformers have a 3rd tap. They can actually have more than that. You can have multi-tap transformers. I've seen transformers that have as many as 6 different taps. Different taps mean you get different voltages from different parts of a single transformer. So Music and Sound loves their center tap transformers. They use them a lot, I think, on almost all of their systems, probably starting sometime in the late 70s. Before that, I think they're all more standard transformers. So this is supposed to be 24 volt center tap transformer, and what that means is you get a screwdriver here. You have 3 wires on the back that you saw. These are the 3 connections along the bottom of this is a Molex connector. There is a ground wire here, a green one that would be screwed to the wall housing. We don't care about that for what we're doing today. We only care about these 3, and what we're going to measure is it's 24 volts. So if we measure outside pin to outside pin, we should get around 24 volts. If we measure outside pin to center, it should be half, so about 12. And center pin to the other outside pin should also be 12. So let's go ahead and power this up. We're going to use today, so you can see, we're going to put it on this. We're going to use the Fluke 83, tried and trusted and true. And also has a really good display on it that doesn't reflect so much, so it's easy for you to see instead of the X-Tech. I've had this. This is the very first digital multimeter I ever bought. I think I bought it in 1987. And it was really expensive in 1987 compared to analog meters. Digital multimeters were fairly new at that point. So anyway, we're going to power this up. We're going to try to move this so you can see a little bit. Here are our 3 connections. So we're measuring AC volts because low voltage transformers for intercoms are almost always AC transformers. So we're going to go outside to outside and we get 26.8. That's fine. One of the things to understand is AC transformers like the one that powers the N350, the amount of output voltage has to do with the amount of input voltage. So this is being powered by the bench power AC power supply. It's set at 120 volts. In fact, I can show you that. So if we go here and here on the primary side, we have 119.23 volts, that's something like that. The higher your line voltage in your house, the higher the output of the transformer here. The lower your line voltage in your house, the lower the output. But this is a rough measurement. It doesn't have to be dead on. So we got 26.8 there. If we go bottom pin to center pin, it's roughly half, 13 volts. If we go center pin to the other outside pin, also 13.5 volts. So the transformer works fine. Turn that off, turn this off for a minute, and reset so we can look at our N350. All right, so step one's completed. We know our transformer is good. Now what we're going to do is we're going to plug the N350, plug it in to the connector on the transformer plate. Now, caution, warning. Music and Sound likes to put fuses inside their low voltage transformers. They do that for safety, but it's also a pain in the neck. You must never ever plug in or unplug your master station to your transformer while it's powered up. Because if you do that, the shock of plugging it in or unplugging it sometimes will blow the fuse in the transformer, and then the transformer output goes dead and you don't have anything. And then you have to send it to someone like me, unless you know how to do it yourself, to have it fixed. So we're going to make the connection. I have the bench power supply turned off, so I'm going to make the connection. Set's plugged into the transformer here, and we're going to power it up. And indeed, we have no display. Nothing lights up, which is what was reported. Okay. If we put it on, it's on FM, radio, tape, power on, nothing, no sound. However, if we use the intercom buttons, we have door on. If you listen, you can hear a relay click. If we do talk and listen, another relay clicks, so that's good. The other thing that I noticed when I powered it up is I'm hearing a very slight hum out of the speaker here. And also, I'm hearing, I think, let me prop this up a little bit. I'm also hearing a little bit of a buzz or hum out of the low voltage transformer. That usually indicates that the transformer is working really hard, or it could just be old, and when you power it up and put a demand on it, a load on it, it buzzes a little bit. So we'll set our meter back up, and the second test we're going to do is we're going to remeasure our transformer and see what kind of voltage we get coming out of it. So if I can get these probes jammed in here, and I'm looking at the meter on the screen just like you are. So we still have 26.5, so that's good. And 13 and change. And 13 and change. So the transformer is not being overloaded. If the transformer is being overloaded, meaning that the device is demanding much more power from the transformer than it reasonably can supply, the voltage output of the transformer would drop noticeably. Could drop as much as, down to 1 or 2 volts because it's seriously overloaded. Also, in those situations, the transformer here tends to get hot pretty fast. This one, not so much. So I don't think that's the problem. Turn this off, unplug this. So we have some sort of reasonably serious problem with our N350, or maybe not. Maybe it's a simple problem. It's hard to say. Now, before I started making this video today, I did spend a little bit of time and sort of perused over the schematics for this. It's a fairly straightforward design. I don't anticipate a lot of problems with it. However, as I told Jacob when I talked to him on the phone during our conversation, he said the magic word. The magic word was lightning. If it is lightning damaged, then all bets are off as to what the damage is and how hard or easy it will be to fix. The way this is designed, let me get a nut driver here. It's going to be hard to work on as it is assembled at the moment. Take these two screws out. And when you have to take a set apart, one of the things you have to do is you have to maintain control over all the little screws and nuts, especially on music and sound systems, because they love their screws, nuts, and washers. And there's going to be a whole ton of them when you take it apart. So you got to have some way to contain them, otherwise they're going to end up in the carpet and then you're not going to find them all. What we need to do is we need to disassemble this, because while I can get to this part of the board and this part of the board, I can't get to the main board underneath. This is the tuner, and under this board is the control board with a display, and I need to be able to get to under all of this. So at this point, it will also be easier just to take the whole thing apart. By doing that also, we're not moving the faceplate around, which is in really nice shape, and we don't want to scratch it or mar it up or anything like that. So the next step is going to be take it all apart. The majority of this part of this video will probably end up being a time-lapse video, because watching me stand here and unscrew things, and there isn't always necessarily that much to say, is rather boring. So I think the first thing to do is we're going to remove the chassis from the faceplate, which are screws around the perimeter of the chassis plate. Now, if you're doing this, the other thing Music and Sound likes to do is they use a fair number of different sizes of screws and things. So if you're doing this, you may want to separate them into different containers or little plastic bags so you remember where they all go. There's that. This is the green support strap thing that's on almost all Music and Sound intercoms. I think it's a pain in the neck, but that's just me. Alright, so we'll get rid of that. Fold this up for a second, and to lift it out of the chassis, I do believe that we have to pull these knobs off the front like that, because they go through. And the other thing we have to do is we have to take the wires off the back of the speaker cone, because the speaker cone's screwed to the faceplate, and I don't care about that. I have speaker cones. Now, one of the things, it's a tip, you have a black wire and a red wire, and there is polarity to a speaker cone. And what you want to do is you want to make sure that when you put it back in the same way. Now, in this particular case, right here on the frame of the speaker, right there, there's a red dot. That was drawn on there by somebody at the Music and Sound factory or at the speaker factory when the speaker was made. If you don't have a red dot, what you do is you take a red Sharpie and you make your own red dot. So when it comes time to hook the wires back up, you hook them up the right way. Now, I'm not going to get super fancy here with this. I'm just going to simply heat up the solder joints and wiggle the wires out of the tabs. We'll worry about putting it back together nicely later on. So we'll do that, and if I'm right, we can just lift this out and we can put this aside. Now, one of the things I noticed is this panel here on the front is kind of loose. Looks like it had some glue or something that held it down. We'll take care of that when we get this all fixed. So here's our chassis assembly. Have all our fancy gold button caps and lever caps and all these other things on here. Here's our LED display assembly. You want to be kind of careful with all of this. Again, if you're fixing something for someone, you want it to be better when you're done, not worse. And scratching things up really annoys people. So we'll set it on a cloth here on a shop rag just to keep it safe. So the next thing I want to do is take the tuner assembly out, and to do that, lots of 1/4 inch nuts. One of the useful tools can be one of these. This is a screwdriver magnetizer demagnetizer. Now, I've never actually used the demagnetizing part because they always lose their magnetizing on their own. Is magnetizing a word? Anyway, so this comes in handy. You pass the screwdriver through it a few times. It will magnetize it, and then you can pick up little nuts and washers and put them in the cup. Like that, and then we'll use our little screwdriver that is now magnetized to try to fish the washers. Musical Sound loves their washers. They have nuts and washers on everything. It's crazy. Alright, so this board should kind of lift out, and there are two plug-in connections here and here, and there's our tuner assembly. Now, one of the things that you can think about, this is going to go in the work tub, out of the way, off the workbench, where it will be nice and safe. Now we need to take this plate off, and this plate is just screwed on, and as I mentioned, so there's a big machine screw, and then these two on the corner are smaller long machine screws. See, lots of different kinds of screws. You don't want to make it too easy and have all the screws be the same size. That would be crazy. Okay, the other thing is on this post here and this post here, there are more washers. Why there aren't washers on all four posts? I don't know. The other thing was when I took these screws out, which screw down through the board here, there are these two spacers to space the board off. So a good way to do this is, here's one of our long machine screws that we took out. You'll notice there's a washer on that too, because you got to have a lot of washers. Put the spacers back on the long screws that went through them, like that, so you remember later on where it goes. So here's this plate, that goes out of the way, and now we have access to the entire board. And one of the things I see right off, which may be a problem, maybe not, is this transistor right here, this one that sits on this little heatsink assembly, looks like it's gotten rather hot over the years. So that could be a typical problem, or it could be a bigger problem. At this point, we don't really know. So the next thing I want to do is take the board out of the chassis. This ground wire is screwed to that grounding plate right there with a machine screw with a washer, of course. And there's this one. When you take something apart like this, one of the things that I usually do, because I'm not usually making a video, I'm just quietly standing here taking something apart. Some person back in 1988 stood over this, just as I'm doing right now, and put this all together. Don't know how it was done. Don't know who it was done by. There are initials. Music and Sound. I'll show you in a second as I put this washer back on the machine screw. Right here, there's a sheet or a sticker that contains information. Model N350, serial number, alignment was done by DM, audio was MB, and final was somebody L or S or something hard to say, and that was 2/10 of 89, and the warranty expired on May 1st, 1990. There, it's upside down. They like to document all of that. So in many respects, these are sort of handmade units. I'm sure the circuit boards were made by some assembly house. I don't think that they were handmade. Alright, so it looks like you have to unplug it like that. From the display board, which is here. So now we're going to take the display board out, because this big chassis piece here, this big sheet metal piece, we don't really need that. That's just going to be in our way, because we can sort of, what I like to call, Frankenstein it together. Okay, so we got 3 nuts, and we have, of course, 3 washers, because you know, you never can have enough washers. And then here we have a standoff with a washer underneath it, of course. And now we can take the display board out of the unit also. And this can go in the work tub. All right, so now we're down to the 2 most essential things. Put that over there. We have our main board, and what they call it in the schematic, they call it the motherboard, which is interesting. But anyway, so this is our main board and our display keypad board here. One of the things to think about when you're working on something like this, because there is a certain amount of testing involved as you go along to see what is and isn't working, and if you're making progress and all those other kind of things, is the radio tuner that we took off first is sort of a sub-assembly of the rest of the unit. So those 2 plugs that we unplugged go here and here, and that connects the tuner to the rest of the set. The tuner is a module. It's a separate assembly. You can use this as an intercom and not have a tuner connected to it, because you just don't have any radio then. The tuner isn't integral to what the rest of this board does, at least usually. For audio testing, which is what you need, you do have auxiliary inputs here. You have RCA jacks. And I would have to look in the schematic to tell you which one is which, because of course the other thing Music and Sound likes to do or not do is label things. But at least 2 of them are inputs. 1 could be an output, I'm not sure. You can use an audio cable, an RCA cable, and you can plug it into these and plug it into your phone or something like that as a music source and play music through this input through the board, and it comes out the speaker. Of course, you have to connect a speaker to it, but that's easy to do. So you don't necessarily have to worry about the radio tuner at the moment. What we need to do is get this board working first. Okay, we're kind of set up here. The first thing you have to do when you're going to try to diagnose why something doesn't work at all, which is what we have here, is the very first thing you have to do is you have to measure voltages. You have to look at the circuitry from the connection where the power goes into the board, which is the transformer connection, through the power supply sections to see what is and isn't working. Now we know it works to some degree because you heard the clicking of the relays and you heard a little bit of humming sound out of the speaker. So something is alive to some degree, but not enough to make it work correctly. Now, I looked at the schematic, and one of the things I saw in the schematic is it has a fairly simple power supply. There's a 15-volt regulator here, and there's a 5-volt regulator over here. The 15-volt regulator, for the most part, powers all of this. The 5-volt regulator here powers all of this. All of these integrated circuits and what's on the display keypad board, and I think probably the radio tuner, I didn't focus on that all that much, are all 5 volts. If you think about it, if you can't get this to turn on, it may be because it's not being powered, and it may be because this voltage regulator has failed. Now, if it has failed, that brings up the next question, which is always, why did it fail? But we'll worry about that once we get it to do something. So what I'm going to do is, I have it plugged into the transformer, but the power supply is turned off. And what I like to do is, and this is a good way to do it, because as I have talked about in other videos, Music and Sound, at a point, there's no labeling on this board. There's no silk screen, there's no component designation. This would be you know, in their vernacular, this would be U something. I would have to look on the schematic to see. It's got a number, and U is for an integrated circuit, which is what this is, and it would have some number. So this would be U something, U something, U something, U something. None of this is labeled on here. So it makes it more challenging to work on because you have to deduce where everything is. And integrated circuits are pretty easy because they're big and there's like only one of these and there's only a couple of those and they're in this section. So, you know, you can figure it out. But when you're talking about resistors and diodes and capacitors and things, there's a whole bunch of them. So it makes it more complicated. So you got one here and the other one is mounted on this aluminum heatsink right here. And it's in here. It's in the side right here. There are two other devices attached here to the heat sink. These are transistors and this is part of the amplifier. But this is what we care about initially. So what I like to do is, because things aren't marked and you have to flip the board back and forth, I take my little extra fine point red Sharpie and I mark on the back side of the board where the connections are of what I want to measure, because it just makes it easier. It only takes a second to do that. You do it with the transformer turned off, and that way you don't accidentally short something out, and then you turn it on and you just probe and see what you get, and you're all good from there. So we're going to go ahead and we're going to turn this on, power it up. And I noticed, let's see if our transformer is humming. Yes, a little bit. It's buzzing. I wouldn't say it was humming. And we're going to be measuring, this time we're measuring DC volts. So we'll do our 15 volt one first because that is the first one in the chain of regulators. And I have to look on the screen to see what we have. We have 14.95, close enough. And this one's probably going to be about 24-ish or maybe 32. That's probably fine also. So it's a chain of things. So this is regulating voltage, and then this one over here is being powered probably by this one. Again, I only looked at the schematic briefly, but that's the way it's normally done. So if we go down here and we test this one, here we have 13.4, and if we jump back up here, is it the same? Works better if you actually touch the pads. Come on. See, there we go. That's probably better. 14.9. So maybe not. And then if we go here and here, we actually have 5 volts. So it's not the regulator. It's something else. And that's interesting. So now is the part where we turn this off. And now thinking has to happen. So I'll be back. I'm back. And it's actually been 2 days since I recorded the first part of this video. And to forewarn you all now, this is going to be a multi-part series because of issues. And I ended the last section with, now I got to think about it. And a lot of thinking has taken place. So far, this is where we are. I was able to I'm going to turn this on. And you should be able to see, it's a little hard to see. We have a working display and we have functional control buttons. The other things that I know for a fact are the chime module works fine, no problem. The AM/FM tuner works okay too, no problems as far as I can tell. It hasn't been realigned or anything like that, but it functions and it will receive stations. So that's all good too. Odds are those are both great. Where we are with this at this point is we have no audio and we have no intercom functions. We do have relays that click like that. Cleaned all the switches and controls just to eliminate it off the list of things that could cause operational problems. What I found is this is most likely, as near as anyone can predict or say, this is a lightning damage set. It's also interesting in that I believe it has been worked on by someone in the past. It looks to me like components were removed and then reinstalled. I don't think that they were replaced because the date codes on all the integrated circuits are all relatively close to each other. So I think somebody made an attempt, whether it has something to do with when the lightning damage thing happened, because from what I understand, that could be 20 years ago. So 20 years ago, somebody could have worked on it. It was interesting to see they were sort of following the same path of diagnosing problems that I was on, but at some point they simply stopped. And then I think everything went back in. You can tell that to some degree because there was a certain, this is all wave soldered when it was the board was manufactured, and there was a lot of hand soldering, or some hand soldering, not a lot, but some. So that's what we found. The things I know for a fact, the way I was able to get the display and the controls working again are, so there is this. This is a microcontroller. Whoops. Now all the electrons fell out. This is a microcontroller. It has to do with, it's the interface between the controls on the display segments that light up, and the AM/FM tuner. It does a lot of different things. This is, and it's a fairly common off-the-shelf part for its day, not so much for today. This is the original one. I have a substitute one in right now because until we get audio out of the set, it's hard to tell whether this functions fully and correctly or not. As I was thinking about, this is the afternoon and evening at the end of the first day, the first segment of this video. I spent a lot of time doing voltage measurements, looking for voltage related problems as to why the display and the controls weren't working. And I wasn't really getting anywhere. I did verify that for the most part everything was functioning correctly. There was a pass transistor, which is this one. It was functioning and it does test as good, but the voltage regulation from it was incorrect. It's supposed to be an 8-volt circuit and it was only putting out 5 and change. So that was replaced. That took care of that problem, but I still didn't have any display. And I was thinking about what would cause that, and I wasn't coming up with any brilliant ideas, of course, until I did. What occurred to me that evening was microcontrollers like this have a clock in them, and not this kind of clock, a timing clock to allow it to function correctly. And the clocks in here require a crystal to make them work. Now, I've been fixing intercoms for almost 40 years. And in 40 years, I cannot remember ever a time that I had a bad crystal. So, lightning damage? Possibly. Hard to say. Never can prove it absolutely, but it seems likely based on all the other problems I've found. So, I replaced the crystal, and voila, the display and the keyboard works. The reason it wasn't working before is no crystal, no clock, microprocessor or microcontrollers turned off, nothing works. So that solved that problem. That was good. That was a small victory. Then we got down to what are we going to do next. So by default, what you do is, I already had worked on all of the power supply circuits and they all seemed to be within tolerance. They weren't perfect, but they were close enough for a mass-produced product like this. So then it becomes a component by component search, because lightning damage is random and it doesn't follow any pattern at all. You can have 2 identical sets installed in the same house and have the same lightning strike, which creates damage, and each set will be damaged differently. It becomes a component by component search to figure out what's good and what's not, and I do it section by section because all circuit boards are divided into sections, and when you find damage in one section, then you check every single part in that section to see what else is damaged. It really is almost an individual component by component check. Some things go fast, some things don't. So here is the pile of parts that have been replaced. We already talked about the microcontroller and the crystal. We talked about the little pass transistor. Here we have another transistor. We have, this is a small voltage regulator. We have a couple small, 3 small signal transistors, and we have 2, 4, 5 little diodes that are bad. I did replace a couple, some capacitors, not because they were necessarily bad, but they didn't measure as close to good as I wanted them to, and I was already working on that section of the board, and they're going to get replaced anyway, so we did that. And then we have what seems to be the heart of the matter. We'll move these out of the way. We have 1, 2, 3, 4, 5, 6 integrated circuits that test as either partially operational or outright faulty. Each one of these are different. These two are the same, actually, these two little ones. And each one of these is different, and they're responsible for doing a lot of different things in the set, and these all need to be replaced. So on Friday afternoon, I decided it was time to make a parts order. I sat down, and normally we order, first choice is Mauser, second choice is DigiKey, third choice is Newark, or also referred to as Element 14. And those are my three primary suppliers for probably 95% of all the components we buy. What it turns out is each one of these integrated circuits are all fairly common integrated circuits, but not from those suppliers, not any longer in these package types. So these are all DIP packages. DIP means dual inline packages. These four are 14-pin ICs, and these little ones are 8. On all three of those sites, these integrated circuits are all available. However, they're not available in DIP packages. They're only available in different varieties of miniature surface mount packages, which isn't going to work for me because this is a through-hole board. It requires these kind of packages. The other choice would be you can buy a lot of what are called breakout boards. They're little adapter boards that would solder to the main board in place of this, and then they have surface mount pads on top of the breakout board, and you put surface mount parts, and I'm not going to do all of that. That's a lot of extra work. Some of this has to do with the still ever going on chip shortage in the world, and those of you who might follow a little bit of this, you probably are more familiar of it with car manufacturers where they still have somewhat limited production because they can't get all of the really fancy expensive chips that they buy to put in the computers in cars nowadays. And what's happened is, since the chip manufacturers, the companies that make these kind of parts, still have somewhat limited production, there's still all kinds of supply chain problems and things like that, they're faced with a dilemma of, okay, what are we going to do? We have limited production, so are we going to make integrated circuits that are put in cars that we sell to General Motors and Ford and we get $80 a piece for them, or are we going to use our production capability to make these little old-fashioned and moderately obsolete style integrated circuits that we get 40 cents a piece for? Well, you do the math and you already know the answer. To obtain these, we're going to order them from a trusted supplier that's overseas, because that's where these parts exist. Now, one of the things you have to think about is, I know some people would go, oh, you know, you can go find those online, you can buy them on eBay, and you can do this and you can do that. I don't trust that. When I order parts, I have to trust that they are actually the genuine parts, they're actually brand new, and they're not counterfeit in some way or another. And when you order parts like this from some seller on eBay, you don't know what you're getting. Can't do that. I have to have a better, higher level of certainty that the parts I'm getting are the parts that I want and need and are correct. These are all going to get ordered from a supplier overseas, and as we normally do here, oh, and also the cost to do that is way less. There is what I would consider to be a second tier supplier, not one of the top 3 that we use, but the next level down. And they are a specialty supplier. They are located in England. They have these available. However, for instance, one like this, their price on it is $15. So again, do the math. If on an average each one of these is $12 or $15, that's a lot of money for what it is. I can order this same part from our other overseas supplier and pay just a fraction of that. So that's what we're going to do. And the other thing that enables me to do is, since shipping from overseas is much more expensive than in the United States, instead of only buying one of each from the supplier in England because they are so darn expensive, I am now going to buy at least 20 of each, because the cost per chip is lower, and also the extra cost for the DHL delivery is spread across a larger number of parts, so shipping per part is a lot less. Anyway, that's where we are with this at the moment. I talked to the customer about this actually a few minutes ago. I was getting ready to record this part of this video and process it and everything, and he called for an update, which I gave him. Lightning damage sets or lightning damage sets. He did inquire about, well, you know, don't you have a replacement board? And it's like, well, yes, but that's a more expensive option than fixing it. This is the end of part one of what I guess will be the N350 saga. And as they say in the movies, confidence is high. We should be able to get it fixed. It's just a matter of sorting out and replacing the parts that I think are bad. One of the most interesting thing is actually this microcontroller. This is a NEC part. It's a part number D1703C, but the suffix number is 019. And it turns out for this microcontroller, there are at least, I would guess, 19 versions of it. Because there are, when you do a search for them, you can search the basic part number and come up with parts for sale. And then there seems to be the suffix number. There's like 010, 0111, 01 or 011, 012, 013, all the way up. The last one I could find was a 018, but I couldn't find a 019. And I did check other N350s that I have on the shelf, and they all have 019 chips also. The problem is in the data sheet for these, it doesn't specify what the suffix number means. Basic part number is a basic part number, but they must be variations. Maybe they were updated over time, or maybe they were produced for different, slightly different applications. I don't know that for a fact. And to figure that out, since I can't find any information online about it, it would be a matter of printing out probably 4 or 5 sets of data sheets, maybe from 014 through 019, and then sitting down diligently reading through them to try to figure out if there are some sort of subtle differences. Anyway, this is important because it is sort of the brain of the system. Fortunately, it doesn't contain any proprietary firmware or anything like that. It is an off-the-shelf chip, so if it has to be replaced, that is a possibility. And hopefully, if you need a 019 and you can't find it, a 018 will make do. But I don't know that for a fact. You never know until you actually either find the information or try. So this is the end of part one. Parts will be ordered today. They shouldn't take probably more than 3, 4, maybe 5 days to get, because DHL is pretty timely. And then I'll be back on it. So look forward to part 2. Coming soon to a theater near you. I hope you found this interesting and perhaps helpful. If it is, give it a thumbs up on YouTube, because that helps us just a little bit. There'll be a banner right here that shows you how to subscribe. Go to our YouTube homepage, click on the bell, and when you click on the bell, click on it to receive all notifications. And every time we post a new video, you'll get a notification and you can watch it. That's all for today. See you on the next video.